Inheritance is an extremely important topic that we must cover, not just because it allows us to write scalable and robust code, but it's because it's something that we use on a daily basis. We use it all the time, whether or not if we know it. In fact, we've used inheritance since the first time that we wrote code, back on the second day with our Hello World application. And that's because everything inherits from system.object. System.object is a class, and everything, and when I say everything, I mean everything, integers, booleans, strings, the person class that we wrote, everything inherits from system.object. And that means that everything can be converted, or I'm going to use the word cast, to an object. Casting is basically converting, but that's programmer speak for converting. We just can't say convert. We have to create a new word for it. So in order to do that, we need first an object variable. Well, we can do that in three different ways. We can define the variable. Let's call this foo. Just like this, using system.object, or we can get rid of the system dot and just use object with a capital O, or there's a keyword, object with a lowercase o. Either way, you get the same object data type. Most of the time, though, you're going to use just the keyword with the lowercase o. And I mentioned casting. Casting requires a different syntax, naturally, and that syntax involves using a set of parentheses, and inside of the parentheses is going to be the data type that we want to cast to. So in this case, we want to cast a value to object. So object is going to go in here, and then we have the value that we want to cast. So let's just choose the number 10. So we are taking the number 10, casting it as an object, and then storing it in foo. Now we're not actually changing the value here. The value still exists, but it's contained within a new box, if you will. It's contained within an object box. And we can get that value anytime we wanted to by casting back to an integer. So we use the same syntax. Int bar, we want to cast foo as an int, and then bar is 10. So let's go ahead and write that to the console. And there we go, 10. Now let's look at the overloads for write line. We have many to go through. Let's just find the one I want. There we go. There is an overload to pass an object to write line, and that's because everything is an object. So you don't have to have a long value or an integer value or a float or a double or decimal or anything like that. All you need is an object. And everything is an object, so you could pass an object to console write line if you wanted to. In fact, let's create a new person object and pass that to write line. And we get the name of the data type, myfirstproject.myfirstdatatypes.person. And the reason why we get that is because the person data type cannot be easily converted to a string. In fact, we haven't defined the toString method to allow the conversion between person to string. So in that case, we just get the data type name. But get this, let's move this person object outside and let's create the variable Jeremy, new person. Whenever we use this Jeremy object, we will see from IntelliSense that it has a toString method. Why is that there? That is being inherited from the object data type. If we were to look at the object data type, which we really can't, but I'm going to right click on object and I'm going to go to definition. This is going to pull up just some metadata for the object data type. The object data type is living inside of the .NET runtime's DLLs, so we can't really look at the source code. But if we write a class like person and we right click and go to definition, it's going to take us to that person class. So if we right click on object and go to definition, it's going to give us just some of the basic information like the properties and the methods, but it's not going to give us the actual code of those properties and methods. So we can see here that the object class defines several different methods. There are two equals methods. There's a get hash code, there's a get type, there's a member-wise clone, there's a reference equals, and then there's a toString. So our person object, if we were to look back at IntelliSense, has a toString method, and that's because person is inheriting from object. Now, if we look at our person code, we don't see that happening at all. That's just done for us. It's automatic. We don't have to do that. But we could specify that if we wanted to. And we do that by using some syntax after the class name. So we have public class person, and then we use a colon, and then whatever data type that we want to inherit from. In this case, it's object, and that's being done automatically for us. So we don't have to do that, but we could if we wanted to. And we will get back into looking at that syntax in a few moments whenever we actually start doing our own inheritance. I want to sort out this toString issue. So let's go ahead and finish that out. I want the person class to have its own implementation of toString, because as it is right now, toString doesn't really give us anything useful. But we can provide our own implementation of toString by using a feature called overriding. Overriding is a feature of object-oriented programming. It's not just C#. And we can override properties and methods of the base class being object. And so to do that, we go down to, well, we can go anywhere within our code file, but I'm going to put it at the bottom. We first specify public because toString has to be public. And then we use a keyword called override. Now, don't confuse override with overloading. Overloading is dealing with methods. We have the say hello method with 3 different overloads. Overriding, we are overriding something from the parent class or the base class. So we use the keyword override, and whenever I press the space key, IntelliSense is going to give us the information as to what we can override. And it knows this because of some syntax within our object code, and we'll look at that a little later. But we have 3 options. We can override equals, get hash code, or toString. Obviously, we want to go with toString, and so whenever I hit enter, it's going to fill out the rest of this method. Now, as it is right now, it's calling the base class's toString method. In this case, the base is object, and that's the functionality that we want to avoid because it doesn't really give us anything useful. So one thing to note here, the keyword base, this is referring to the base class, or the class that person inherits from, which is object. And so it's calling object.toString. That's obviously not something we want to do. We want to return, let's say, the first name and last name. So let's concatenate first name with a space and then last name, so that whenever we call the toString method, it's going to return the first and last name of this person. So whenever we run this code, and let's make sure, yes, we did fill that out. Whenever we run it, we are going to see Jeremy. Now, we're not seeing the last name because we created the person object without a last name. So let's go ahead and do the last name. Run it again, and we will see Jeremy McPeak. Now, it's great that this code works, but there's the problem that we're calling toString. If you remember, we got on this discussion because we just passed a person object. We weren't calling toString, which returns a string. So as this code is, we are returning a string to the right line method. We don't want to do that. We just want to pass in the object. So if we run this, we will see that our toString method is automatically being executed for us. Now there's 2 things I want to be absolutely clear on. Well, one thing I want to be clear on, another thing I want to clarify, and that is whenever we cast something to an object, that value is still there. It does not change. So we have taken a person object and assigned it as an object, but There's nothing different about that person object. It's just being contained within an object box. So if we pass foo to WriteLine, we are going to get the same results, because what is contained within foo is a person object, and it calls the toString method of the person class, not of the object class. So keep that in mind. The value doesn't change, or the object doesn't change. We just store it in a different way. And the thing that I want to clarify is, before I said that we had to cast something as an object by using the casting syntax, and that was incorrect of me to say so. Since person derives from object, we can just assign the person object to an object variable, as we've done here, because a person object is an object. But if we wanted to take foo and convert it to a person object, we would have to use the casting syntax. So we would have to do Jeremy2 person foo. And the reason being because the compiler knows a person object is an object, but it doesn't know that the object that we have assigned to foo is a person object. So we have to tell the compiler, this is a person object, convert it for me. So that's, I apologize for saying that incorrectly at first. And I'm sure that's as clear as mud, and I apologize for steamrolling through this and saying object way too many times. But the problem with talking about inheritance and the object data type is that it's all hidden from us. We don't get to see the code that makes this all work. And at least for me, I need to see the code in order for something to click. I mean, you can tell me how something works all day long, but if I don't see it, then it just doesn't exist. So that's why we're not done today. We are going to write our own class that inherits from person. The idea being we are writing management software for a retail establishment. And we have the person class, but we need more specific versions of people because we need to represent employees. And we could also represent customers or managers or just any person that we need to represent. So the first thing we need to do is create a code file for our new class. So we'll go to the Solution Explorer, right click on My First Data Types, Add, and then Class. And this class is going to represent an individual employee, so I'm going to call it employee. And this is just habit for me. I typically make my classes public. Now, there are obviously going to be times when you don't want to do that, but in this case, it really doesn't matter. So we have employee created, but we want to inherit from person. And if you remember from a few moments ago, the syntax to do so requires the use of a colon, followed by the name of the class that we want to inherit from. So now, employee inherits from person. So this means we get person's first name and last name properties. We also get the say hello methods, but we don't get the constructors. In fact, if we go and change person with employee, we are going to get a red squiggly because it says that employee, there we go, does not contain a constructor that takes 2 arguments. So we do have to write our own constructor, but we don't have to repeat all of the code that we have here. Now, we will eventually have to repeat some of it, but we'll get to that here in a moment. Because the first thing we really want is just a constructor with 2 arguments. So let's do public employee. The first argument needs to be the first name. And then we also need a last name. Now, in the person class, last name was optional, but we don't want an optional last name for our employees. We want them to have a last name. So we're not going to make last name optional. And we have the power to do that. Inheritance lets us do that. So now we just need to write the code to initialize our employee class. Now, we've already written a lot of code to do that within our person class. We properly validate the first name parameter. We kind of validate the last name. Since last name defaults as an empty string, we can't have an empty string for a last name. So we have to do some extra validation for last name, at least for our employee class. And we also set the first name and last name properties. One of the tenets of object-oriented programming is do not repeat yourself. Dry. Do not repeat yourself. If we were to copy and paste this code and modify the validation for the last name parameter, we would be repeating ourselves. It would be really great if we could just reuse this code with minimal effort, and we can. Let's go back to employee, and we are going to use some syntax that looks kind of like the syntax that we used to call an overloaded constructor. If you'll remember, whenever we talked about overloading and constructors, we used a syntax of colon this, and then we could pass the parameters that we needed to the overload. Well, we kind of do the same thing. Instead of saying this, we say base. And this is going to call the constructor for person, because base is, or person is our base class. So we are going to call the person constructor. It has all of the logic there that we need. We just need to do a little bit of tweaking for the validation of last name. So let's, reuse what code is there. So we're calling the person constructor, passing in first name. We might as well pass in last name. And that's going to work just fine. The only thing that we need to do is validate to make sure that last name is not empty. Because our validation in person, we check if it's null, if it's white space, but we make sure that it can be empty. Well, we don't want that flexibility. We want the restriction that last name cannot be null, empty, or white space. So all we really need to do is check to see if last name is empty. And we could use the comparison to empty, but I'm just going to do is null or empty. And so if last name is empty, and I need to spell last name correctly, then we want to throw a new argument exception that last name cannot be null, empty, or white space. Let's take a moment and marvel at what we've just done with, let's see, we start at 8, end at 18 with 10 lines of code. We have created a class that has a first name and last name property. It has 3 say hello methods, and it also has tweaked validation for the last name parameter. We did all of that with 10 lines of code, all because of inheritance. And this is the power of inheritance. It allows us to take code that we have already written and reuse it. Now, of course, that we have to use common sense. We obviously only want to create classes that are going to resemble different types of a person. But by doing so, by using inheritance, we have reused all of the code that we wrote within person, and we did so with just 10 lines of code. That's pretty awesome if you ask me, and that's just the power of inheritance. And before we go on, I want to show you what happens if we do the console.writeLine thing and pass Jeremy. We will see Jeremy McPeak. Well, why do we see that? Now, employee inherits from person. Person overrides the toString method of the object data type. So because employee is inheriting from person, it is using this overridden version of toString. But that doesn't mean that we can't write our own version of toString for employee, and we will do that in a few minutes. Now I want another property. I want one that represents the position of this employee, because we can have an owner, or we can have a manager, or a sales representative, or someone who restocks the shelves. So let's create a string property. We're going to call it, for the lack of a better word, position. And like the last name and first name properties in the person class, we want this to be privately set. Now this is actually going to cause an issue as far as last name and first name are concerned, and we'll talk about that in a minute. But we also need the position to be added as a parameter, so we will do position. We also need to perform the validation for position, so if string is null or empty position, or is null or white space, then throw a new argument exception that position cannot be null, empty, or white space. We have that sorted out, and now we just need to assign the value to position. So that's the wrong way. We need the property position. And now let's override the toString method, because it would be nice if we call the toString method for it to say the first name and last name, but also the position of that employee. So once again, we would do public override, and then toString is listed, so we'll go ahead and do that. Now, the person class returns the first name and last name. So we can reuse that by using base.toString. And we would just need to concatenate a comma, let's say, followed by a space, and then position. So whenever we create an employee, let's say that I am the owner. Why not? I'm writing the software. So whenever we run this, we will see Jeremy McPeak, owner, because now the toString method has been overridden inside of employee. So it's going to call the base class, which is person, its toString method, which is going to concatenate the first name and last name, and then we take that value, concatenate the position as well. So now we have taken the code from person and modified it to our own specific needs within employee. Now there is a slight little issue with our first name and last name properties. We have set them to be privately set, and private is private. Even inherited classes cannot see private members. So if we try to set a value to first name or last name within employee, we are going to come up with an issue. For example, let's do last name equals last name. Even though we are already doing this because we are calling the base class's constructor, we can see automatically that we have this red squiggly and that something isn't going to work. It says last name cannot be used in this context because the set accessor is inaccessible. So basically, because we have set the set accessor for last name to be private, it can only be set inside of person. Sometimes we will want that, and other times we won't. So if we want to be able to set first name and last name in the derived classes, we have to change private to what's called protected. Protected is somewhat like private, except that it can be seen in derived It can be seen in derived classes. So it's still not accessible outside of the person class, but it's accessible to the person class and the employee class and any other class that we use to inherit from person. So now if we go back to employee, we will see that the red squiggly is gone. And in fact, let's change this to, say, first name so that we can no. That's a little confusing. Let's just say I changed this. So if we go back and run this code, we are going to see that we can now change that value because we changed it from private to protected to make it available to all of the derived classes. So we might want to do the same thing for position. I don't know what we would derive from employee unless if we wanted to be more specific, like owner or manager or something like that. But for future proofing, we might want to just say this can be protected so that we can access it and modify it later within a derived class if we want to. Because even though employee is a derived class from person, we could write another class that derives from employee. Well, before we go on, let's get rid of this line of code because we do not want to change the last name of our employee, at least to that value. And it would be nice if we could modify the say hello method to have a different greeting because these are employees. If anyone walks into the store, regardless of their position, they should be nice to the employees and be as helpful as possible. So instead of saying hello there, it would be nice if they could say, hi, how may I help you? And then their name. Well, we can do that by overriding the say hello method. But, how do we specify that? Because whenever we did the override for our toString method, the say hello method is not listed here. So we need to go back to the person class to tell the compiler that it's okay to override one or multiple say hello methods. And really the only one that we care about is the one with a string parameter, because that's where the greeting is. We don't really care about the other overloads because the one with the person object is concatenating the first name and last name. That's perfectly fine. The one that's accepting multiple names is just concatenating those together. That's fine as well. So the only one that we care about is the one with the greeting. So we need to make this overload to be overridden. And we do so by using a keyword called virtual. And we put it after the access modifier and before the return type. So it's public virtual string say hello. That's a mouthful, but the key is virtual. If something is virtual, it can be overridden. So let's go back to the employee class, and we can see that say hello is now listed. So we can choose say hello. And the code that is automatically generated is going to call the base class's version of say hello. That's obviously not what we want. We want to be nicer to whoever we are saying hello to, so we want to say hi. How may I help you, comma. Then we want to concatenate the name. And since that's a question, we should end it with a question mark. So we have now overridden the say hello method that accepts a name. So let's test this out. Let's go to program.cs. Let's create a person object. We'll call him customer. Customer. New person. We'll give him a first name and last name of John Doe. And then, since I am an employee, I am going to say hello to the customer. And if we run this, we will see, hi, how may I help you, John Doe? So by using inheritance, we were able to create a new class called employee, which reused a good portion of the functionality of the person class. And the key phrase is reuse. Yes, we could have written employee exactly as we had done the person class, but in doing so, we would have repeated a lot of the code that we had already written. And as I've said earlier, one of the tenets of object-oriented programming is do not repeat yourself. Repetition takes time, and it can lead to errors if you don't repeat things exactly as you need to. With inheritance, you avoid the repetition completely. There's another type of class which is called an abstract class, and it's used exclusively with inheritance, but we use it in a slightly different way, and we will talk about that tomorrow.